Hello everyone, welcome. Thank you for joining me. My name is Corey Pike. This is my individual video assignment for ICS 382 at Metropolitan State University. And we'll be talking about naval communication security. This will be a report of ComSec practices and policies. So we'll begin by defining terms, important terms, and give a brief overview. We'll also talk about the technical control of telecommunications, how information gets from one place to another, and the equipment or hardware that's involved. And then we'll also talk about the ComSec policies and practices of a certain publication. So where we begin, what is ComSec? Well, ComSec is communication security, which is the prevention of unauthorized access to telecommunications traffic or to any written information that is transmitted or transferred. So there are several different types of ComSec, one of them being cryptographic, which is the encryption and decryption of data. There's emission security, which is the minimization and control of the leaking of information. There's physical security, which is the protection against unauthorized access of the hardware or equipment. There's transmission security, TRANSEC, which is the prevention of communication channel interception, like signal hijacking and such. So there are different classification levels of information systems. So each information system will be given a classification level depending on the type of information that is stored or transmitted through it. So the different levels we have are top secret, secret, confidential. There's also some others, which is TSSCI, which is like a step above top secret, which is top secret sensitive compartmented information. This is where the need to know and the requirement for access is really important. There's also an unclassified but for official use only. This relates to certain documents that are sensitive to personnel information but doesn't require classification. So here's some other important terms. So we'll be talking about EKMS, which is Electronic Key Management System. This is the policies and procedures regarding cryptographic and physical security and handling of ComSec material. This is stuff that's provided and regulated by the National Security Agency. We'll also be talking about KeyMat, which is keying material. These keys are the unique algorithms that are loaded into cryptographic materials to allow it to encrypt and decrypt the information. We'll also be talking about NOC, which is a Network Operations Center. This can be thought of as a service provider. So this will provide RF and IP services to deployed assets. And then this is a quote from the EKMS 1 Bravo, which we'll talk about later. So EKMS is an interoperable collection of systems, facilities, and components developed by the services and agencies of the U.S. government to automate the planning, ordering, filling, generation, distribution, accountability, storage, usage, destruction, and management of electronic keys and other types of ComSec material. The overall EKMS architecture consists of 4 layers or tiers, which we'll get into later. But you can see just by that how important this system is. And then we'll get into radio or radar spectrum standards. So these are frequency ranges that are used for radio frequency services that get to distant ships and ground forces. So the first standard that's set by the International Telecommunications Union, you can see that it begins with extremely low frequency, or ELF, and it goes all the way down to extremely high frequency, EHF. It actually goes past that as well, but these are the most important frequency ranges. Well, not most important, but the most common. And then also on the right, there's the Institute of Electrical and Electronic Engineers standards. This one's a little bit different. It has HF, VHF, and UHF, which are included in the ITU standards, but after that they have their own band names for specific services. So they have long wave, short wave, commercial band. They have a cross or exotic band. And they have Kurse band, which is German for short. And they have V band and W band. So here's a comparison of different radio frequency bands. You can see at the top there's also one set by NATO, which they just give lettering A, B, C, D, E, F. And you can see the hertz at the bottom on the range that it uses for each frequency band. This is important because this will tell you what type of communication service it is by the frequency range, because information travels along these frequency ranges differently, which we could talk about later. So let's get into the technical control of telecommunications. So here is some of the communication transport equipment. So we start with routers and switches. So this will forward IP traffic to its destinations. We have cryptographic devices. This is often referred to as ComSec. So these devices encrypt and decrypt information being exchanged between end users. Some examples of those, there's a TAC lane, which you can see up top here. This TAC lane is a KG 175, and this one is a 175 alpha. There's also KIV7s. This one here is a KIV7 mic. There's also multiplexers, which act as an aggregate for multiple data channels. So you could have different services coming from, different routers or different switches, like for phones or something. So they'll go into these multiplexers, and then from there, everything goes down one channel. So it's easier to channel, I guess. So there's also data converters, which translates and converts data types. Some examples of those are serial data to IP information, or analog to digital, which you might be familiar with. Some other ones, there's modems, terminals, antennas, and satellites. So these incorporate the complete RF path, the radio frequency path. So this completes the path to transmit and or receive data between shore stations and deployed assets. So some of these data transport methods include satellite communications. So the primary satellite communications deal with SHF, that frequency range. So some of these include Defense Satellite Communication System, or wideband global SATCOM. So these are frequency bands that are specifically for military uses. There's also commercial broadband satellite programs or wideband, CBSP, CWSP. These are commercial bands that can be used for both commercial and military. The military can basically rent these time slots to use these specific bands for their missions. There's also international maritime satellite communications. These are older systems. Not many use these satellites anymore. They're going out of commission. There's also EHF and UHF for voice and IP traffic. There's also direct cable links. Like for shore-to-shore, they use a lot of fiber connections. When ships are in port, they use a lot of fiber connections. And then also, what dictates how data is transferred depends on their ship capabilities, which kind of go hand in hand with this idea of ADNS variance, automated digital network system. So there's increment 1, increment 2 alpha, increment 2 bravo, and increment 3. As you can see, there's a diagram here for kind of how that all relates. It gets pretty complicated, but if you know what you're looking at, it could be simple. So this is an example of a simple equipment string, a very typical one over SHF. This is an increment 2 Bravo ship. So here we have the ship side equipment. So their service request, will go up to the satellite, come down to an Earth station or a gateway that they'll call it. So this is their equipment here, and then it'll follow some kind of fiber network, which is transferred using these converters. And then they'll get to a NOC, or a service provider, which will give the ship their services, whether that be phones, internet, other military systems. So that's the data path it follows. Okay, then we'll get into ComSec policies and practices. So the main publication that handles a lot of this ComSec regulation is this Navy publication, EKMS 1 Bravo. So it's a publication of policies and procedures for electronic key management system. It's referred to as the Bible of all things ComSec related. It's roughly 750 pages of regulations and procedures, not including the table of contents, the indexes, the annexes. So it's a lot of pages. Some of the information included on it, there's responsibilities of each tier and position of authority. There's information on operating ComSec devices. There's information on handling ComSec material and conducting inventory on that material. Also on maintaining records, on incident reporting, requirements of security and the need to know, like I mentioned earlier. And then there's lots more than that. So here's some instruction examples out of that publication. So the rule of the EKMS manager, this is designated in writing by the CO, the commanding officer. He or she is the primary advisor on matters concerning the security and handling of ComSec material. So each base that uses or handles ComSec material will have an EKMS manager. They act as the central point of contact at that base for anything relating to ComSec at that base. Another rule, user passwords for key loaders. So these passwords are unclassified but sensitive, must be stored in a locked drawer or security container, must contain 6 to 12 alphanumeric case sensitive characters. So key loaders, or SKLs as they're referred to, simple key loaders, are used to load keys onto crypto devices. Keys are required by the devices to be able to encrypt and decrypt data. SKLs hold up to top secret keys, and that they must be treated as such. Here are some other instruction examples. So ComSec incident reporting. There are 4 types of ComSec incident reports. There's an initial, an amplifying, a final, and an interim. These are submitted for each ComSec incident. So each type of report allows for more information to follow the initial incident. This allows for proper remediation, as some incidents are more threatening than others. And there's pages and pages on like degrees of the severity of each incident. There's also a rule on requirement for access or need to know. This is what I mentioned earlier. So access to ComSec material must be restricted to properly cleared individuals with a valid need to know. The fact that an individual has a security clearance and or holds a certain rank or position, I should say, does not entitle an individual access to ComSec material. This rule follows after proper security clearance within the EKMS 1 Bravo. Security clearance is not permission, in itself is not permission to access ComSec material. This allows for better accountability and safeguarding of this sensitive material. So that is the end of this presentation, but the need for communication security never ends. Thank you for joining me.